Okay, so welcome back. Today we're going to do a practice that's going to involve, again, this practice of sort of seemingly expanding our awareness, but in reality, we're not really expanding our awareness. There's no walls that we're building. It just seemingly seems to be so. We are able to consciously hold more and allow our nervous system to have that increased zone of tolerance so that we can feel as if we can hold more. And this is an exercise that you can really do in terms of noticing two spots in your body and seeing if you can simultaneously sense the perception of both those spots. And today what we're going to do is we're going to increase that to 3 spots, and then if we can, the whole body. Before we do that, though, I do want to talk about a brand new research that just came out in Scientific Reports, literally published 2022, so in the last 2 months or so. And the reason why I want to bring this up is because I will bring this up in terms of any new research that comes up on breathing or how we breathe, because we did about 4 weeks of breathing and going into the mechanism of various breathings and extending the exhale and various things like that. And this report says reading on a smartphone affects sigh generation, so sighing like this. Okay. Brain activity and comprehension. Right? So there's really good research that has shown that when you read something, if you read something on a smartphone or a piece of paper, that you'll comprehend, you'll understand the piece of paper more. And they're trying to understand why this actually happens. Okay. So I'm going to read the abstract, which is the short part at the beginning of the paper. Electronic devices have become an indispensable part of our daily lives. I think we would all agree with that. While their negative aspects have been reported. One disadvantage is that reading comprehension is reduced when reading from an electronic device. So if you have kids and they're testing on electronic devices, maybe see if you can do a paper version of it. The cause of this deficit in performance is unclear. In this study, we investigated the cause of comprehension decline when reading on a smartphone by simultaneously measuring respirations and brain activity. So respirations and brain activity, all right? Pretty important things that should be happening when we're reading something, whether it's on a piece of paper or a smartphone. We found that compared to reading on a paper medium, reading on a smartphone elicits fewer sighs. So you're sighing less. You're sighing less. Does this include computer screens? Do not know. I have the sense when I read from a computer screen that my eyes get more strained, that I feel like the front of my brain. They didn't do this study. They didn't do the sigh generation, but I believe there is less comprehension with reading from a computer screen than reading from a piece of paper. We found that compared to reading on a paper medium, reading on a smartphone elicits fewer sighs, promotes brain overactivity in the prefrontal cortex, and results in reduced comprehension. Reading on a smartphone affected sigh frequency, but not normal breathing, suggesting that normal breathing and sigh generation are mediated by pathways differentially influenced by the visual environment. A path analysis suggests that the interactive relationship between sigh inhibition and overactivity in the prefrontal cortex causes comprehension decline. These findings provide new insight into, listen to this, respiration-mediated mechanisms of cognitive function. respiration mediated, so breath mediated, right? Mechanisms of how our brain and mind are working. Right? These findings provide new insights into the respiration mediated mechanisms of cognitive functioning. In recent years, reading and studying on electronic devices has become more common. Although electronic devices have benefited mankind tremendously, they cause eye strain and headaches and lead to poor reading comprehension. The link between visual environment, so our visual environment, right, what we're seeing, and cognitive performance has been reported in basic research. The decline in comprehension when reading from an electronic device might be due to poor concentration levels or different sensory processing circuits, which might be associated with physiological states, including brain and physiological activity levels. Even if the content of the text is the same, reading comprehension may be different depending on the visual context. Because vision has dominant influence on other senses when it comes to sensory integration or cross-modality, visual input might also affect brain state and physiological condition. As such, brain activity and physiological changes likely exist as mediating variables in the relationship between the visual environment and cognitive performance. We focused on respiration and brain activity as potential mediators. Previous research indicates that overactivity in the brain is associated with poor narrative comprehension. So when our brain is too active, like in a state of stress or anxiety, that we have poor comprehension, right? When you're stressed or anxious and I'm trying to tell you something, if you're stressed or anxious, how much are you going to actually really comprehend or understand what I'm doing? Wait, can you say that again? Sorry, I was totally stressed about my, whatever, right? So what are you doing? There's overactivity, and yet you're getting this stimulus or something else. You're like, stop, right? That's just what I do. I freak out. So previous research indicates that overactivity in the brain is associated with poor narrative content comprehension. Many studies have reported associations between respiration and various cognitive function. In these studies, a reciprocal relationship between respiration and cognitive function was found. Respiration is affected by cognitive load or emotion, stress, and anxiety, which alters the depth and rhythm of breathing, right? What happens when you're stressed and anxious? Shallow, rapid breathing. Conversely, respiratory patterns affect frontal cortex and hippocampus functions. Hippocampus is an important part of your brain that's important for memory, and consequently the formation of memories. Attention to breathing has also been shown to enhance memory performance. See, did you realize you were coming to a memory performance class? I don't think so. Attention to breathing has been shown to enhance memory performance. Furthermore, brain activity is entrained to the respiratory cycle. We know that. However, no studies have examined the relationship between the visual environment and respiration. According to intersensory integration mechanisms, how cool is this stuff, right? This is all Kundalini, by the way. Intersensory, between sensory, integrating, right? You have areas in your brain that do this. Let's help them out a little bit. It is known that visual information can alter information from other senses. Wow, isn't that cool? Including touch, taste, smell, and hearing. What you're seeing can actually alter what you're smelling. However, information from other senses rarely affects visual sense. These findings indicate that vision is dominant over the other senses, and it's quite possible that visual environments influence various functioning, including that of the respiratory system. Given the findings that the use of digital devices lowers cognitive performance, it is probable that the visual environment affects cognitive performance. regarding cascade processes between the visual environment and cognitive performance, the relationships between the visual environment and brain function and cognitive performance, respiration and cognitive performance, and respiration and brain function have been clearly established. However, it is unclear how the visual environment affects respiration and brain function. Therefore, this study investigated the involved mechanisms in an exploratory model. So what they found when they compared the same text reading on a smartphone or an electronic device versus reading on paper, and they measured respiration and brain activity, is that they found that the brain activity in the prefrontal cortex when you were reading on a smartphone was increased. And we sighed less. We sighed less. So imagine what you do. How do you feel after you sigh? It's pretty good. So imagine, right? Every time maybe you turn the paper, you sigh. I don't know. They didn't like go into clarifying, when you sigh, but that we sigh less. And when we sigh, breathing actually will affect our brain activity. The visual cortex, what we're seeing will affect the brain activity. What we're reading will actually, or what we're seeing, our visual, what we're looking at will affect our respiration, which will therefore affect our cognitive functioning through the brain, through the activity of the brain. All right. So again, it doesn't matter what you're doing, whether you're reading on a computer screen or your smartphone. The thing is to really bring awareness to what. Now, they haven't done the study where they had people read on a smartphone and breathe, right, on regular rates or take sighs, but that's clearly the next study, and you should do that irregardless of if they do that study or not. Right? Is anytime you do open up an electronic device or a smartphone, is you notice how you're breathing. Am I breathing through my nose? Am I breathing rapid or shallow? And you start taking slow, deep breaths. And maybe you throw in a sigh, or you do a little humming sound when you breathe. As you're sending your text or your okay. All right. This research is just going to start coming out. We're going to start looking at various ways of respiration, how it affects brain function, memory, happiness, sadness, et cetera, et cetera. All right. All right. The next thing I want to take just 5 minutes on is that there is to just be aware in your practice of, and I think we've sort of talked about it a little bit because we are evolutionarily primed to survive. We've talked about it a bit, but it's this concept of negativity bias, and that they've actually done significant studies on this, that our brains are actually wired to have a negativity bias, in that we are going to perceive a negative experience much more intense than the same, let's say, reciprocal positive experience. All right. So they've done a lot of studies on this, where, for instance, they've offered people with the same percentage of winning. They've said you have 50% of winning $150 or 50% of losing $100. And many people didn't take the bet because there was increased sense of sort of loss with the potential of even losing $100 versus even winning more, even though there was an exact same percentage chance of either one of those occurring. They've done studies where, for instance, they have hooked people up to machines that measure electrical information in the brain, or electrical inputs in the brain. and they'll flash images up on the screen, and the images will be characterized as neutral, negative, or positive. And they will actually look at the amount of firing that occurs in the neurons as the images are being flashed. And there is an equal percentage chance of each image coming up. So it's not like there is an increased propensity to have negative images come up or positive images come up. Same chance. When the negative images are displayed, that there is much more frequent and intense firing that occurs in the brain. Now, if you've learned anything in this class, it's that the repetition of a signal, even in your brain, is actually what causes us to remember things or be good at them. If you have a repetition of a signal between two neurons that is very quick and intense, you are more likely going to set a connection between those neurons than, for instance, if something is just up, up, up. Okay. So it's important that as you go through your practices, that you pay attention to this bias that is intrinsic in all of us, and that you may have a tendency of recalling negative events that have happened in your life. You may have a tendency of recalling negative sessions of meditations over positive ones. Maybe negative physiological experiences that you've had over positive ones. Even though you had 70% positive ones, we ruminate on the 5% negative ones. And there's a reason for this, because it's about survival. And so evolutionarily, when we were hunters gatherers and we worried about survival nonstop, it was they think that it was the tribes that were constantly looking for food, that were constantly defending themselves, et cetera, that were more likely to survive. And so the genes that had a propensity to have a sort of worry, let's say, or a, kind of feel as if you're constantly being threatened and you want to survive. And so you were preparing and doing this and doing that and doing that, that those were the genes that have actually been selected for. And now we're seeing that sort of take hold in terms of the news. We're more likely to believe things if they actually have a negative spin to them. This shows up in politics, in science, et cetera, et cetera. And so to keep in mind that, let's say, even though you might be sitting and you're 80% of your meditation, if you have like one negative thing, that you might ruminate on that negative experience more and sort of maybe even blow it out of proportion, as opposed to the whole of what occurred. And it's a very well studied. And so if you think of it more as a neuronal firing that's occurring, I have a tendency of being able to like notice that and being able then to redirect that, like, oh, wow, interesting. I'm going, like, my neurons are really firing in that negative biased way. There's a sense of threat that's occurring there. There's a sense of sort of survival, and noticing that. And clearly practices like gratitude practices, meditation practices, breath practices, things like that can really kind of help balance that negativity bias. But just as you go along and you sort of perceive your own experiences, that maybe if you sat for 30 minutes, that your brain may sort of latch on to one negative experience that happened during that 30 minutes and not everything else. So just kind of keep that in mind as you go through your practice. All right.